All right, good afternoon. My name is Kevin Carpenter. I'm a volunteer at CppCon, and I'm fortunate enough today to have Eric Niebler and David Hollman with me. And we're going to talk about their upcoming talk at the convention this year. But I got to ask you guys, you're both veterans of CppCon, right?
Oh yeah, yeah. I've been going to CppCon for I think as long as there's been CppCon. I mean, until this year, it's been in my backyard.
That's true. That's right.
Makes no sense not to go. Yeah.
Absolutely. What about you, David?
I've been a couple of years. 2016, I think, was my first one. But yeah, no, I very much enjoy it.
So for the people that are going to watch this that are new coming to CppCon, what's your favorite thing you guys like about the convention that you look forward to each year?
I mean, I just like seeing all my C++ friends again. It's not a very helpful thing, but we're not very cliquish. I mean, just come up to us and chat. You know, there's the group of us on the committee that see each other 3 times a year anyway, plus any of these other extra things. And so we kind of tend to go out and meet together, but they're a fantastic group of people just to come up to and chat with us. I'm easy to find. I have blue hair. Just come up and, put me in the back and talk to me. And I'll open up and you can join our group. So whatever happens. But the talks are, I was going to say, the people saying that the people is is my favorite part is saying a lot because the talks are fantastic. They're better than pretty much any conference I go to, any technical conference I go to anywhere. So.
Well, I'd have to second that because as great as the talks are, all the real action seems to happen either before the talks or in between the talks or after the talks when you actually get to rub elbows with these people and talk with get the real story and find out a little bit more about the people that you've maybe have heard about or the proposals that they are advancing or hear more about the talk that they actually just gave and ask extra questions. It's a really great opportunity to meet people in the industry and learn some new things.
Yeah, I have to say I love getting a chance to talk to everybody. And, we all work on C++ and we all work at different companies, but it's amazing the range of what we actually do when we're working at those companies, Yeah. So I'm with you. I like talking with the people.
Was that a ranges pun?
It could be just for Eric.
Yeah.
So your guys' talk this year is Unifying Abstractions for Async in C++. So I got to ask, what got you both working on this topic so much? Is it because of the committee?
Well, I can answer for myself. So I'm not actually talking about ranges. Like there's going to be next to nothing about ranges in this talk, but actually ranges was kind of how I got interested in this topic. Once I learned a little bit about coroutines, I realized we can build asynchronous ranges and loop over ranges asynchronously using coroutines. And then there's all this overlap with the reactive side of things. So much has been done in reactive programming in other languages like Java and C#, and even in C++. But with coroutines, we get first-class support for reactive programming. But once you dip your toe into the world of async, you find it kind of sucks you in. And once you schedule work to happen asynchronously, now you need to say where that work happens, and you need to offer the programmer ways of controlling where that work happens. And you also need to worry about things like, well, how do you make this efficient? Like coroutines, you can use coroutines to hide the latency of a pointer dereference. We need async abstractions that are that efficient. So yeah, this rabbit hole goes really deep, and so I got sucked into that, and I've been kind of digging my way back out for the past year and a half. Finally coming up for air, and I'm excited to show people what we've been doing. Yeah.
So yeah, I came at it from the absolute opposite side of things, which is probably why this is such an exciting opportunity in terms of to give a talk together, to kind of come from both perspectives. I came from high performance computing world. I've been in HPC for 10 years now. and came from distributed memory programming models. My PhD is actually in quantum chemistry, but I very quickly moved towards programming models out of that, just because the field was so complex. And I thought the interesting part of it was kind of trying to give the scientists the abstractions they need and not actually doing the science itself. And so that took me into distributed memory programming models. I've worked on something that's kind of a number of different frameworks that have been some variant of executors for about 6 years now. And when I got involved in the C++ committee in 2016, the first thing I just immediately gravitated to was this effort on executors. And Eric and Kirk and Lewis got involved about 2 years after that. Rappersville. When was that?
I feel like it's probably about 1.5 years ago.
Yeah.
Yeah.
And the rest is history. So that's my background and perspective on this talk, or that I'm trying to bring.
Right on. So on the talk, is this stuff that's actually already in the standard or going to be in the 20 standard, or is it proposal type items? I guess let me expand on that and say, what's the big takeaway that you're both looking forward to for attendees to take from the talk?
Well, to answer your first question, we missed the boat for C++20. We really wanted there to be some sort of a scheduling solution in C++20. We didn't quite make it. So this is probably all work that's either going to be targeting a separate TS or else C++23. That would be my hope.
Yep. That is, there are parts of it. The other piece of that is the part that would have gotten into 20 anyway, is not really interesting, as interesting as the stuff that we want to talk about in our talk. The stuff that was potentially targeting 20 and had enough kind of time and momentum behind it to maybe make it into 20 was not the kind of flexible, asynchronous, two-way channels of communication that we are really interested in talking about in this talk. So that stuff is definitely targeting 23, and we have a fairly good reason to believe that it'll actually make it this time. I know we've been saying that for quite some time, but it's finally coalescing, and it's really looking nice. So.
But even there, a lot of the stuff that we end up working to get into the standard, I mean, is code that you can generally end up getting, TSs on or pieces on that you can still use now, right?
Absolutely. And this has been done. We are not breaking new ground here. We're breaking new ground perhaps in the level of genericness, but we're not breaking new ground in terms of the patterns or in terms of the constructs. These are things that have been in libraries. I work on a library that dates back to 2009, and it's been doing essentially this kind of executor type thing, asynchrony, since 2009 in the domain of HPC. And there are countless other examples of this kind of thing that you can get your hands on. And it's just a matter of us actually kind of authors of those libraries coalescing on something that they can actually agree on and meet up on. And that's the real challenge for this standard. But using these things in a domain-specific way is definitely something people should already be looking into, because that's the direction computers are going.
Yeah, and what I think is really new about the work that we've been doing lately and what we'll be presenting is that all of the existing work on executors have started at the bottom layer, either at the hardware or at the runtime platform that supports parallelism and concurrency, and trying to build abstractions up from that. And what we've been doing instead is taking a look at asynchronous algorithms, like way up here, and trying to find the abstractions that are necessary in order to express asynchrony at the level that programmers are going to be interacting with it, and pushing those abstractions down and finding ways that the lower level platforms can express their functionality in terms of APIs that can be consumed generically from the algorithms. And I think that's what's new, and I think that's what's going to be really exciting. And I think if I were to offer one kind of a teaser takeaway, it would be that there is enormous amount of power, potential, flexibility, and efficiency to be gained by doing asynchrony lazily.
Yes, absolutely.
You know, I have to say, hearing both of your different takes on this, I am really excited to see the talk. So you'll see my name underneath the one that I'm going to, you know, as one that I'll be going to see. And so with that, we'll close this up so we can get other people to see this and be excited about the talk too. And I look forward to seeing you guys at the convention in 90 days or so.
Great.
Yeah, thank you very much.
Thanks a lot,
Thanks, guys.
Kevin.
Have a great weekend.
You too. Bye.
Yeah.